Welcome back, everybody. Today we are going to do our second to last video from geometry. So I promise we're close to being done. Everything we're going to talk about today is about inscribed angles. So an inscribed angle is an angle whose vertex is on a circle. So the vertex is on the circle, and its sides contain chords of the circle. So essentially an inscribed angle, the vertex is on the angle, and then the other two parts of it are going to go out into the circle somewhere and end up ending on the circle. This arc that is created by the end points of the angle is called the intercepted arc. Okay, so this is your inscribed angle. This is your intercepted arc. So there are some properties that we have with them. The measure of an inscribed angle is half the measure of its intercepted arc, which means this angle is half the measure of this arc, this angle is half the measure of this arc, and this angle is half the measure of this arc. Now again, my inner right is not working, so this is going to be all written with my mouse, so I do apologize. If you have questions, please let me know. Okay, so this also means that the measure of my arc, let's say in case 1, for example, AC, the measure of my arc AC then is going to be double, so 2 times the measure of the angle. Okay, so for example, if this arc was 40 degrees, this angle would be 20 degrees. If this angle was 15 degrees, then you double it to get that this arc is 30 degrees. Okay, so the angle is half the arc, and the arc is double the angle. So let's do an example. I want to find the measure of angle RST. So I actually want to find the measure of angle RST. So that means the arc that I am trying to find is the arc that I'm going to use is arc RT. So remember, your arc, or your angle, is half the measure of the arc. So to find this angle, we're going to say that that is equal to 1/2 the measure of my arc RT. Okay, so what that means is I'm going to cut this arc in half. So the measure of angle RST equals 1/2 of 120, which is going to give you 60 degrees. It's as easy as that. All right, so this angle right here is 60 degrees. Now in the next one, they want us to find the arc SU. So I want to find this arc. Now to figure out what angle corresponds to it is you want to find the two endpoints that work for it. Okay? Now, I do understand there's an endpoint here, but if I go here, there's no other chord to make it an angle. That's just one line. So I'm going to use these two chords to say that the angle that corresponds to arc SU is SRU. Okay, so to find the arc measure, remember your arc measure is double the measure of your angle. So to find the measure of arc SU, that is 2 times the measure of angle SRU. So to find that, the measure of arc SU is going to be double the angle, which is 40 degrees. So 2 times 40, which is going to give you 80 degrees. And that's it. The hardest part is going to be to find which angle corresponds with which arc. So like I did here, maybe get a pen, a highlighter, a marker, a pencil, like colored pencils, and use different colors to mark it off so you can see what relates. All right? So moving on. Now we're going to talk about multiple inscribed angles. So if inscribed angles of a circle intercept the same arc, then that means those angles are congruent. What that means is if I look at angle ACB, its ends are at A and B. ADB, its endpoints are at A and B. AEB, its angles are at A and B. So that means all of these angles are congruent. Okay? So again, if they all end at the same arcs or at the same endpoints, then they're congruent. An easy way to do this is name the angles. If their first and last letters are the exact same, then they're congruent. Okay, so this is only for inscribed angles. The other one is if an inscribed angle subtends a semicircle, meaning if an inscribed angle's endpoints lie on the diameter, then that angle is a right angle. Whereas if you think about it, half of a circle is 180, half of a circle, which is half of 180, would be 90. Okay? And you can kind of tell it creates a right angle there. So again, if your endpoints of your inscribed angle are on a diameter, your angle is equal to 90 degrees. So let's go ahead and do an example. I want to find the value of x. So if you see, RT is a diameter, and the angle we're talking about is angle RQT, which means its endpoints are on this diameter. So I know that this angle is equal to 90 degrees. So to find what x is, I'm just going to set 4x plus 6 equal to 90. So 4x plus 6 is equal to 90. And then you just solve for x like normal. Subtract your 6 on both sides. You're going to get 4x is equal to 84. And when you divide by 4, you're going to get that x is equal to 21. And that's it, because it only asks for x. If you plug 21 back in, you would get back at 90. All right? So again, the reason I knew that was equal to 90 is because its endpoints are on a diameter. Now let's do the next one. Over here, they want me to find the measure of angle ADC. So I want to find the measure of angle ADC. So that's the angle I want to find. Now if we look at the other one that is given to us, they give me ABC. Okay? So now you can tell it starts at A, ends at C. Starts at A, ends at C. So that means both of these angles are congruent to each other. All right? So because I know those angles are congruent, I can say, or I can set them equal to each other. So I can say that 10y minus 28 is equal to 7y minus 1. And then you just solve. So I'm going to add a 28 to both sides. That gives me 10y is equal to 7y plus 27. Then subtract your 7y on both sides. So we're going to get that 3y is equal to 27. And finally, you're going to divide both sides by 3. That should be a 7, not a 1. And you're going to get that y is equal to 9. Now, it did not ask for y. It asked for the measure of angle ADC. So I'm going to plug that in here. So 7 times 9 is 63. Minus 1 is going to give you 62 degrees. And that's it. So again, if you have an angle whose endpoints are on a diameter, that angle is 90 degrees. And if you have two angles whose endpoints lie on the same spot, or whose endpoints are the same, those angles are congruent. All right? And the last thing that we're going to do is going to be talking about two tangent rays. So If a tangent and a secant, or chord, intersect on a circle, then the measure of the angle formed is half the measure of its intercepted arc, which means I have this tangent line BC and this secant line BA, and they both meet at B. So what that means is that this angle, ABC, is equal to half the measure of this entire arc right here. Okay, so again, if I have two rays that intersect at the same point on a circle, then this arc that is created by them is half. So let's do an example. They want me to find the measure of angle BCD. So they want me to find this angle measure right here, BCD. Now it is not 90 degrees. 90 degrees is this whole angle, ACD. Okay, so BCD is this angle right here. Now if you notice, these two lines intersect right here at C, which means we're going to use that formula, that the angle BCD is going to be half the measure of arc BC. So this is equal to 1/2 my measure of arc BC. That's easy enough. So my measure of angle BCD is equal to 1/2 142, which when you divide that out, you're going to get that your angle of BCD is equal to 71 degrees. And that's it. Now let's do the opposite. Now it's asking for the measure of arc ABC. So I want this entire arc right here, ABC. Well, if the angle is half the arc, then the arc has to be double the angle. So that means my angle ACD is 90, which means it's double that, so my arc ABC is 180 degrees. And you can tell that that arc is going to be half of your circle, which is 180 degrees. All right, so what I want you to do now is go ahead and pause the video, work on these on your own, and then when you're done, unpause and check your answers. All right, so for this first one, we want to find the measure of ADC. So I want to find the measure of arc ADC. ADC. So to find the arc of ADC, we know that it's going to be double the angle whose endpoints are A and C. So the only angle whose endpoints are A and C is this angle right here, ABC, which they tell me is 135 degrees right here. So that means my measure of arc ADC is double the measure of angle ABC So 2 times 135 is going to give you 270. All right, for the next one, they want us to find the measure of angle DAE. So DAE is the angle they want me to find. So that means the arc whose endpoints are D and E is just arc DE. So your angle is half the measure of that arc. So that is equal to 1/2 arc DE. Sorry, that's a D, not a P. So when I solve that, I'm going to get 1/2 76, which is equal to 38. All right, moving on. They want us to find the measure, or excuse me, they want us to find the value of z. So I can tell that this angle has its endpoints on the diameter, which means this angle is equal to 90 degrees. So to solve for z, you just set this equal to 90 degrees. So 8z minus 6 equal to 90. Add your 6 over. So you get 8z is equal to 96. And then you divide by 8. And you're going to get that z is equal to 12. And there you go. And finally, they want us to find the measure of angle RST, or excuse me, STU. I don't know where that came from. STU. So I want to find the measure of angle STU. So again, because this angle endpoint lies on the circle, that means it is half the measure of that arc. So this is equal to 1/2 the measure of arc ST. So all we're going to do is 1/2 166, and 1/2 of 166 is going to give you 83 degrees. And finally, they want us to find the measure of arc SR. So to find the measure of arc SR, we can see that it is related to this angle SRQ. So your arc is going to be double the measure of the angle. So this is equal to 2 times the measure of angle SRQ. So 2 times 71. And that gives you 142 degrees. And there you go. So again, I do apologize for my terrible handwriting. I had to use the mouse, and it's not the easiest. So if you have any questions at all, feel free to email me. Otherwise, go ahead and get started on the 12-3 workbook, or excuse me, worksheet. And that is not due until Sunday at midnight, like always. So good luck, and email me if you have anything. Have a good week.